Hello student, myself Prof Ajay Yadav. In today's session we are discussing about immersion effect and rate drop. Okay, before we are discussing about immersion effect, in previous video we discussed different pigment absorb different wavelength of light. So what is the immersion effect? Immersion and his team performed an experiment. Immersion and his team performed an experiment and they found out the rate of photosynthesis implanted at different wavelength of light. So Emerson performed experiment in 1957. Okay, then Emerson and his team performed an experiment and they found the rate of photosynthesis implanted at different wavelength of light. Okay, so Emerson and his team performed experiment and they found out the rate of photosynthesis implanted at different wavelength of light. And Emerson and they measure the rate of photosynthesis as quantum yield. Okay, so what is quantum yield? Quantum yield is defined as the amount of oxygen is released per quantum of light absorbed. Okay, so what is quantum yield? Quantum is defined as the rate of the amount of oxygen is released per quantum of light. So this immersion effect, the result of rate of photosynthesis represented in the form of graph. So on the y-axis rate of photosynthesis. Okay, on the x-axis he plotted wavelength, that is 400, 500, 600 and 700, that is weak pure. Okay, so Emerson observed the rate of photosynthesis decline after red region. Okay, so this declining in the rate of photosynthesis is called as rate drop. Okay, so after red region the rate of photosynthesis gets declined. So what is the rate drop? Okay, so rate drop is defined as the decline in the rate of photosynthesis the declining of rate of photosynthesis after 680 nanometer. Okay, after 680 nanometer means after red light. Okay, so the rate of photosynthesis get decline after red region, that is called as red drop. So Emerson performed experiment or plant exposed into shorter wavelength as well as higher wavelength. So photosynthesis at 700 nanometer. So quantum age get 10. Okay, so another plant exposed at 680 nanometer. The quantum age is 53. But both 700 plus 680, not plus, and 680 provide together, and the quantum age is 72. Okay, so when plant exposed into separately, the quantum age is 10, and in the 680 nanometer quantum age is 53. But when together, shorter wavelength and lower wavelength, shorter and higher wavelength provide together, and the quantum age is 72. So Emerson concluded that the quantum age is higher in shorter wavelength and longer wavelength. And from this experiment, he concluded there are two photosystems. One is 700 photosystem 1, and other is photosystem 2. So photosystem 1 absorbs 700 nanometer of light, and other is 680 nanometer of light. So from the same experiment he concluded there are two photosystems, one is PS1 and other is PS2. So PS1 absorbs 700 nanometer of light, and from PS2 he observed PS2 means photosystem 2 absorbs 680 nanometer of light. So this is the effect of immersion, and this experiment is called as immersion enhancement or immersion effect. Why it is called immersion enhancement? Because when we plant exposed in separately, the quantum age is very low, and at the higher wavelength and at the shorter wavelength the quantum age is 53. When we provide or when we expose plant together, okay, the quantum age is gets high or enhanced. So that is why it is called as immersion enhancement. Okay, so Emerson performed experiment in 1957, and what is the immersion experiment? So immersion experiment, the rate of photosynthesis implanted at different wavelength of light, and they measure the rate of photosynthesis as quantum age. Okay, so what is quantum age? The amount of oxygen is released per quantum of light, that is called as quantum age. So he plotted or he expressed his result in the form of graph. So the rate of photosynthesis, it declined after red region. So this declining in the rate of photosynthesis is called as red drop. So what is the rate drop? Rate drop, the decline of rate of photosynthesis after 680 nanometer. Okay, or after absorbing red light. Okay, so Emerson performed experiment or exposed the plant in the 700 nanometer. The quantum is 10, and another he provide or expose plant in 680 nanometer. The quantum yield is 53. But when he expose plant in together, the quantum yield is 72. So the quantum yield gets enhanced. That is why it is called as immersion enhancement. And from the same experiment, he found out there is two photosystem. There are two photosystem. One is called as PS1 and other is called as PS2. So PS1 absorbs 700 nanometer of light and PS2 absorbs 680 nanometer of light. Thank you.